Ladies and gentlemen, adventurers and future AI architects, welcome to today's exploration of the perilous, puzzling, and oddly exhilarating realm of the Wumpus world. Buckle up, we're diving into the thought experiment that's as much of a test as your AI smarts as it is a challenge to your imagination. So let's get started. Before that, I would like you to like and subscribe our video, and let's dive deeper into the Wumpus world and problem and how what it is in the world of artificial intelligence. So let's just set the stage first. What is the Wumpus world, right? Imagine a dark, grid-like cave filled with dangers and opportunities. Somewhere in the labyrinth lurks the fearsome Wumpus, a monster that will devour you if you stumble upon it. Around the cave are also treacherous pits. Falling into one means an ultimate untimely end. But it's not all doom and gloom. There's a glittering pot of gold hidden in the depths, and you, the brave explorer, must retrieve it. To make matters worse, you're navigating this hostile environment blindfolded. Well, almost. So, what are your tools? Your only tools? Sensory hints. You might smell the stench of the Wumpus nearby, feel the breeze of the nearby pit, or catch the glint of gold. With these clues, you'll piece together a mental map and devise a safe path to treasure and triumph. But wait, you're not the only explorer. Your AI agent is. And your job as the architect is to program the agent to survive, adapt, and succeed in this world. Easy? Not quite. Let's unpack why. So, why the Wumpus World Problem? That's the next aspect that we need to clarify before we move further into this problem in question. So, the Wumpus World Problem is more than just a quirky puzzle. It's a benchmark problem in AI. It teaches us how to reason under uncertainty. How do we make decisions with incomplete information? Number two, model the environment. How can an agent construct a reliable internal map from sensory data? Number three, plan strategically. What's the best course of action to achieve the goal while avoiding the catastrophic risks? If AI is the brain, then problems in the Wumpus world are the mental gym. They build muscles in logic, probability, and decision making. Plus, they're fun, a little like training your AI to be Indiana Jones. So, the AI agent. Let's give a quick overview of what the AI agent is. Your agent is an autonomous explorer with the following capabilities. It has perception. It changes its immediate surroundings. It senses its immediate surroundings for hints, which are the stench, breeze, and glitter that we talked about earlier. It can take action, basically. It can move, grab the gold, shoot an arrow at the Wumpus, or climb out of the cave. It has memory. It remembers where it's been and what it sensed there. And it has logic and inference. It makes educated guesses about where dangers and treasures might be. Here's the challenge. You need to design this agent's brains using tools like propositional logic, probabilistic reasoning, and search algorithms. So, let's break down the Wumpus world further. The Wumpus world is usually represented as a 4x4 grid. With these elements, the Wumpus, it's a stationary but deadly. The adjacent squares reek of its stench, basically. Pits, falling into one is fatal. Nearby squares are breezy, basically. Number 3, gold. Shiny, rewarding, and the ultimate goal of our movement in the Wumpus world problem. And number 4 is safe zones, basically. They are squares with no dangers, but they're blissfully boring. Well, you might like boring, considering there are only two options other than that. Gold at the end and death everywhere else. Your agent starts at a random location, doesn't know where anything is, and every move reveals a little bit more about its environment. Have you played a game called Age of Empires, basically? You have this fog of war that you can't see the rest of the map, but as your troops or your units in the game move around the map, they explore more areas. So it's somewhat like this. The agent it's in a 4x4 grid, and it basically needs to identify the Wumpus, where the Wumpus is and avoid it. It needs to identify where the pits are and avoid them. and it needs to find the goal, which is the end of this place, and there are safe zones where there's particular no action to be taken basically. So let's start at a random location. Let's move on to the logic behind it basically. So to solve the Wumpus World problem, your agents needs to have some serious deductive skills basically. Let's see how. Number one, knowledge representation. Each square can have states: safe, Wumpus, pit, and gold, as we discussed just above earlier. You need to use logical rules. For example, if there's a breeze, at least one adjacent square is a pit basically. So, something like that. And if there's stench, the Wumpus is an adjacent square basically, just like that. Right? So these are two important aspects to avoid the Wumpus and the pit. Even if you step in a safe tile, no issue. And if you stepped into the goal, you'd reach your goal basically. So either way, these are the two important knowledge representations that you need to build up for this problem. Number two is inference. Basically, based on the sensory inputs, the agent deduces likely dangers. For example, if square 2, 2 is breezy, then and 1, 2 is safe, then the pit must be in 3, 2 or 2, 3 basically. Similarly, the third thing that you need to understand basically is the planning and decision making, right? The agent needs to use algorithms like A star search to plan efficient routes across the 4x4 grid. It considers risks by avoiding squares likely to contain the Wumpus basically. So what makes this fun? Let's move on to that section. There's risk management. Your agent can shoot an arrow to kill the Wumpus, but it has only one shot. Miss and you might regret it. So basically there's only one lifeline you have if you step onto the square with the Wumpus. That's the arrow. And you need to just do one accurate hit. If you miss, you don't have the lifeline and you die. If you hit, you're safe, but you probably can't use that method to save yourself from the Wumpus again. So then there's uncertainty. Sometimes the safest move is a gamble. How do you program an agent to take calculated risks in the face of uncertainty? Then there's the victory lap. There's nothing like watching your AI agent dodge death, snatch the gold, and climb out victorious. It's like seeing your child win their first sports match. Except your child is the code that you just wrote, and that code just solved the Wumpus problem basically. So let's move on. Why this is important? Because when we talk about this, there must be some real world parallels about this particular problem. That's why we use this to envisage AI to a degree. So why should you care about the fictional monster in gold? Because the Wumpus world reflects the real world challenges when developing an AI. Robot navigation is one of a clear example for this basically. Think about a robot vacuum avoiding stairs and furnitures. Those small robots that you see cleaning very commonly in videos now, those AI robots don't have an understanding or spatial understanding of where they are moving around to clean or vacuum, right? So for them to basically be safe, they need to avoid stairs, they need to avoid furniture, they need to avoid walking people basically. So for them, it's a Wumpus World problem, just vacuuming the floor of your room basically. Then their autonomy to avoid autonomous vehicles. Similarly, self-driving cars must infer hazards and plan routes. They need to identify their cars, they need to identify the signals, they need to identify pedestrians, they need to identify safe routes, so on and so forth. And they don't understand the environment just like the Wumpus World problem. So they need to explore and make proper deductive decision making when they're running on the roads basically. And then there are exploration systems. Space rovers like NASA's Perseverance must navigate unknown terrains, and again they must solve the Wumpus World problem in the dynamics of the Mars basically. They don't see what are the hazardous environment. They don't understand that environment. They just presume based on the visual input or other inputs what is harmful and what is safe basically. In essence, solving the Wumpus World problem hones the same skills needed for smart autonomous systems in very complex environments. So understanding this is crucial if you want to get good in AI development in environments where there is lack of information and you need to find the safe paths. So basically, let's wrap up this video. So as we're coming from the cave to the cosmos, Wumpus World may seem like a game, but it's a gateway to understanding how intelligent systems interact with unpredictable environments. It challenges us to think about reasoning, learning, and decision-making skills crucial for the smart architectural programming you're here to master. So as you venture into your Wumpus World problems in AI, remember the gold isn't just at the end of the journey. It's about also in the lessons learned along the way. So let us know in the comments below if you got any value here. Like and subscribe as well, and let us know in the comments that what sort of Wumpus problem in around you would you like to solve, basically. So with that, go forth and may AI your AI always dodge the Wumpus in your path.